Okay, in 3.2 we're going to take a look at comparing the rate of change of reactants and products. Most of the equations we looked at in 3.1 were very simple equations with ones as their coefficient. So in this podcast we're going to take a look at what happens when the coefficients aren't 1 and the role that they play. And we're going to learn how to write a rate expression where we can compare the appearance or disappearance of a reactant or product to the appearance or disappearance of another reactant or product. And in order to get this down conceptually, I'm going to do a little demonstration to start us off. Okay, so I'm going to do a demonstration to show you how we can monitor either the reactants or the products in a chemical reaction to determine the rate. So what I'm going to do here is start with 18 sheets of paper, of yellow paper, and I'm going to make a packet using 2 sheets of yellow paper. So let's take a look at what happens. Okay, so I'm going to take a sheet. Okay, so now I'm going to monitor the reaction. I started with 18 sheets, and if I count how many I have left, I have 10 remaining. And I started with no booklets, but now I have 1, 2, 3, 4 booklets. So let's go back and we're going to take a look at how we can monitor either the reactant or the product to determine the rate. Okay, so let's look at the data. So we had 2 pieces of paper that were making 1 booklet. So we could write that as an equation. 2 pieces of paper, let's call them A, make 1 booklet. And we recorded the process for 30 seconds. So let's look at the information that we have. So the paper, we started with 18 pieces of paper, and we started with no booklets. At the end, we had 10 pieces of paper, and we had 4 booklets made. Okay. Okay, so using those numbers, we could look at the change, the change in A, or the change in B, and we can use those numbers to compare the rate of disappearance of A to the rate of the appearance of B. So go ahead and think about this question. How does the rate of disappearance of A, the paper, relate to the B, the appearance of the booklet? So think about this for a minute and go ahead and answer that question. So if you said chose number 2, A disappears at twice the rate that B is appearing, you'd be correct. Well, the bromate ion plus bromine ion plus the hydrogen ion, creating 3 bromine molecules and 3 waters. And we know the value of the change, of the rate of change of the bromate ion, and we want to know what the value of the change in bromine is at the same time. And the reason that they're given negatives is because they are reactants and they're going away. Okay, so let's take a look. So I can basically use my stoich to do this, use the coefficients in the balance equation. So if I say that I have 1.5 times 10 to the minus 2 is the molar for second for the bromate ion. And what I know in the balance equation is I have 1 bromate ion for 5 bromine ions. And if I plug and chug, I end up with 0.075 molar per second change in the bromine ion. Okay, pretty simple. Let's do another. Alright, so in this case, same reaction, bromine disappears at a rate, let's say, of 7.5 times 10 to the minus 2. And we want to know the rate of appearance of bromine, the bromine molecule, at the same time. Okay, so here I have 7.5 times 10 to the minus 2 molar per second of bromine minus, and what I know is there are 5 bromine minuses for 3 bromine molecules. Right? I'm going to get them from the balance equation. One of these, whoops, 5 of these, and I get 3 of these. And if I multiply that out, I'm simply going to get 4.5 times 10 to the minus 2 molar of bromine, whoops, per second. Alright, let's take a look at the two problems at the end. Alright, here are a different reaction. At some point, the rate of disappearance of N2O5 is 0.15 molar per second. I want to know the rate of appearance of O2. So I'm just going to simply take that 0.15 molar per second for N2O5. And what I know is there are 2 N2O5s for every 1 O2. And when I plug and chug that, I get 0.075 molar of O2 per second. Alright, one more. Number 2 says, okay, different reaction, and here I have nitrogen monoxide is 0.10 molar per second. We want to know the disappearance of O2. Okay, so I'm going to take that 0.0100 molar per second of NO, and what I know is I have 4 NOs for every 5 O2s, and that's going to give me 0.0125 molar per second of O2. Okay, we're going to stop right there.